So this is 4.2.4 homogeneous equations. So let's just consider homogeneous equations. Okay, so that is equations that is equal to 0, and your A, B, C are constant. Okay, let's just name this equation as equation number 1, and assumes that the y equal to e to the power mx is the solutions. Okay, so let's differentiate these equations. So if we differentiate these equations, okay, you differentiate e to the power of mx. Okay, you just focus on the x, right? So you differentiate mx, you have m. So m multiplied with the e, so you have m e mx. Okay, then differentiate the second times. Okay, if we differentiate the second times, okay, so means that you still have to focus on the e only. Okay, the differentiate on this one. Okay, if you differentiate on this one, you will have m e mx. Okay, multiply with the m here, so you have m squared e to the power of mx for the second order derivative. Okay, now once you have obtained the second order derivative, okay, what you have to do is you have to substitute the second order, first order, and the y into your equation number 1. So you have the a multiply with the second order derivative, that is m squared e mx. Okay, plus b with the dy dx, so this is the dy dx. Okay, plus with c with the y, and let it equal to 0. Okay, so if you look at these equations, what happened is all the terms that you see here, they are all having e to the power of mx. Okay, so means that basically you can factor out e to the power of mx from those terms. Okay, so what happens if you factor out e to the power of mx from those terms? Okay, so this one, okay, the things that remain are the am squared. Okay, the things that remain here is plus bm, and the things remain here is c only, and they equal to 0. But we know that e to the power of mx cannot be equal to 0. Then the things that equal to 0 will be this equation. Okay, so we have this equation equal to 0. Okay, then let's just name this equation as equation number 2. So your equation number 2 is the auxiliary equations or the characteristic equations of the equation 1. So this equation is the auxiliary equations or the characteristic equation of this equation. Okay. Now once we have known this is actually the auxiliary equations, okay, so then you should know that there are 3 types of roots. Okay, so the first type of roots that you come across is something called real and distinct root. Okay, so the distinct here is means that means different. So it means that you will come across your value of m1 is not equal to m2. So the general solutions for this real and distinct root will be this form. Okay, the second type that you will come across for the roots, it will be real and repeated roots. So this means that you will have m1 equal to m2. Since m1 is equal to m2, then you can say that they are equal to m. Okay, so then the form of the general solution will be this one. Then we come to the third type. So the third type will be the complex conjugate roots. Okay, so this means that you have your n equal to alpha plus minus beta I. So you have imaginary number, and the form of general solution will be this one. Now we come to the first example. Okay, so before we solve the first example, the things that you have to remember is, okay, so you have to change these differential equations into the auxiliary equations. So the way to change this equation into auxiliary equation is, okay, you just have to remember, you just have to, okay, let the derivative equals to m. Okay, so you just have to change the derivative into m. So what you have here is you have the second order derivative. So this second order derivative, you have to change it into m power of 2. This power of 2 because this is second order. Then you have plus 2. And you have this is the first order derivative. So this first order derivative will give you m power of 1. Okay, power of 1 because it's first order. And then you have minus 3. Okay, the y here is not a derivative. If this is not a derivative, it should not have m. Okay, you do not have m in here. Just let it equal to 0. So you just have minus 3 here. Okay, for this auxiliary equations, you can factor out it. Okay, so if you factor out it, you will have m plus 3 m minus 1 equal to 0. Then I will have my m. Okay, so the m is negative 3. And I'll have my m here is actually 1. Okay, I can name it as m1 here, and this is actually your m2. So if you look at this one, this is a case that I say you have real and distinct root where your value of m1 is not equal to the value of m2. Okay, this is negative 3, this is 1, they are obviously not equal. So since you are having real and distinct roots, means that your general solution should be in this form. So your general solution will be y equal to a e to the power of m1x. Your m1 is negative 3. So you have negative 3 multiplied with x. Okay, plus b. Okay, e m2x. Okay, your m2 is 1. So 1 multiplied with x will give you x. So this is the answer for the general solution. Okay, but please take note that instead of writing L1 as minus 3, you also can write the N1 as, okay, 1 and M2 as negative 3. You can have a different order. So if you are using this order, means that your general solution, okay, so y equal to a e to the power of m1x. Your m1 now is 1. 1 multiplied with x will give you x plus b e to the power of mx e to the power of m2x. Okay, m2 is minus 3. So minus 3 multiplied with x will give you minus 3x. So means that, okay, either you can give your answer in this way or you can leave your answer in this way. So both of them are the general solutions for this example. Now we solve the second example. So we're going to use the same concept. So we're going to change the derivative into the m. So then you have here, this is actually the second order derivative. So this is actually, we have to change it into the m power of 2. Okay, minus b12. Okay, this is also a derivative. So this is the first order. We're going to change it into the m power of 1 plus 36y. Okay, the y here is not a derivative. When this is not a derivative, it should not have the m. Okay, so then it's just equal to 0. Alright, okay, so let's just factor out this equation. So if you factor out this equation, basically you will have m minus 6, m minus 6. Okay, so means that your value of m1 is actually 6, your value of m2 is actually 6. If you press your calculator, you just have one value. It means that the value of m is actually repeated. Okay, so that's why it just give you one number 6 only. So since m1 is equal to m2, so we can say that basically they are all m. Okay, we just say that your m is actually equal to 6. Okay, and this is actually the types that I said just now. This is a real and repeated roots because you have the value of m1 equals to the value of m2. Okay, and then we say that it's actually equal to m. Now, real and repeated root will have the general solution in this form. Okay, so your general solution will be y equal to a plus bx e to the power mx. Your m here is 6. So 6 multiplied with x. So this is the answer for the general solution. Now we come to the third example. Again, we're going to use the same concept. We're going to change the derivative into m. So you're going to change this one. This is the second order derivative. Change to m squared. And you have plus 4. And this is first derivative. So you're going to change it into m power 1. Okay, plus 7y. The y is not a derivative. Okay, so it should not have the m. So, but these equations, basically you cannot have the real roots. Okay, so this is this equation you only can solve it by using the quadratic formula. So the quadratic formula says that okay, we will find your a is the ones that next to m squared, that is 1. Your b is actually the one next to the m, so that is 4. And then you have your c here is actually 7. So according to quadratic formula, so m is actually equals to minus b plus minus b squared minus 4ac divided by 2a. So you have minus b, your b is 4, plus minus b squared. So 4 squared minus with 4, a is 1, the c here is 7. So divided by 2a. So now you have minus 4 plus minus, okay, you have a set here. Okay, the things that inside the set, okay, you have 4 square. So 4 square is 16 minus with 4 multiplied with 7 is 28. 16 minus with 28 will give you minus 12. And then we have divided by 2. Okay, so let's just look at the things that is inside the set. Okay, the things that is inside the set, basically you can factor. So if you factor the things that is inside the set, you can think of negative 12 is actually equals to the 4 multiplied with 3 multiplied with negative 1. Divided by 2 will be the same. And the set here actually, okay, you can split it. Okay, so if you split it, okay, we will have the m equal to minus 4 plus minus, okay, let's just split the set here. So so you will have set 4 and you have set 3 and you have set negative 1, okay, divided by 2. And of course for the negative 4 we just copy back. This is the divided by 2 also we copy back. Just let's look at the set here. So the set here, where the set 4 is actually equals to 2. And the set negative 1 will give you I. Okay, so it means that if you simplify, you could have here that is 2 multiplied with set 3 and multiply with I. Okay, then let's just simplify it. Okay, so let's just simplify. Okay, so if you simplify, we will have here that is minus 4 divided by 2. We have the plus minus, and you have 2 set 3i divided by 2. And negative 4 divided by 2 will give you negative 2. Okay, plus minus, okay, the 2 and 2 here you can cancel. The things that remain here, it will be set 3 and I. And then let's just compare this one with our general form. Of course, this is actually the complex conjugate roots. Okay, so you have your m equals to alpha plus minus beta I. So you can see here that actually your alpha is negative 2. Okay, and your beta, what is your beta? Your beta is actually 3. Okay, so as I said earlier, if you have complex conjugate roots, then your general solution will be in this form. So your general solution will be y equal to e to the power of alpha x. So what is your alpha? Your alpha is negative 2. So you have negative 2 multiplied with x. Okay, bracket a cos beta. So your beta is 3. So you have 3 with x, okay, plus b sine, okay, beta. So your beta is 3 with x. So this is the answer for the general solution. Now let's just solve this example 4, the initial value problem. Okay, so just change the derivative into m. So you have the m square here. And you have minus m. And you have minus 6 equal to 0. Okay, let's just factor it. So if you factor it, so you have m minus 3. And this is m plus 2. And you have your value of m1 is 3. And you have your value of m2 is negative 2. Okay, so this is the case that we say that you have real and distinct root because the value of m1 is not equal to the value of m2. Now our form of general solution will be in this form. Okay, so your value of y will be, okay, your general solution will be y equal to a e to the power of m1. So your m1 is 3, m1 multiplied with x, 3 multiplied with x, plus b e to the power of m2x. So m2 is minus 2, so minus 2x. Okay, so this is the general solutions. So let's just name it as let's just name it as equation number 1. Okay, if you look at here, we have the initial condition y0 equal to 1. And we also have another initial condition that is y prime equal to 1. Okay, it means that, okay, instead of doing the substitutions, okay, you have to find out what is y prime first. So let's just find out the y prime from equation number 1. So you differentiate this one, you have y prime. Okay, a is a constant, so just differentiate on exponent only. So if you differentiate the exponent, it will give you 3e 3x. So 3x multiplied with a will give you 3a e 3x. Okay, the same thing happened for the b e to the power negative 2x. Okay, so this gives you 2b e negative 2x. Okay, so let's name it as equation number 2. Now only we look at the initial conditions. So the first initial conditions that we have here is actually y0 equal to 1. So let's just substitute the y0 equal to 1 into your equation number 1. So if you substitute into equation number 1, okay, it means that your y is actually equal to 1. And you will have a, e, 3x. Okay, the x here is actually 0. Plus b, e, negative 2x. The x is 0. Now let's just simplify, okay, the right hand side. So e to the power of 0 is 1. But then we have a plus b only for the right hand side. Okay, obviously we cannot solve it because we have two variables. Let's just name it as equation number 3. Okay, now we need to figure out another equation such that we can solve it. Okay, so we can figure out the next equations by using these initial conditions. Okay, so this initial condition says that you're going to substitute, let's just substitute y prime 0 equal to 1. Okay, let's just substitute into the equations that involve with y prime. That is your equation number 2. So it means that your y prime is actually equal to 1. So you have 1 equal to 3a. So 3a e 3x. The x here is actually 0. Minus with 2b e power of negative 2x. The x is 0. Again, we're going to simplify it. So you have, for the right hand side, you have 3a minus with 2b. So let me name this one as the equation number 4. And now you can see that you have equation number 3 is a plus b, okay, equal to 1. And equation number 4 is 3a minus 2b. So let's say that I want to omit the 3a, okay. So I want to omit the variable a. So I have to make sure that this equation number 3 also have the same coefficients. So I multiply the equation number 3 with the number 3. So equation number 3 multiply with number 3. So you will have 3 equal to 3a plus 3b. Okay, I multiply this equation with number 3. So I name the new equation as 3a. So once I did that way, so you can see that you can compare the equation 4 and the equation 3a. So both of them are having the variable, you have the 3a here. Okay, the variable 3a, you have the same coefficient that is 3 here. Means that you can solve these two equations by using simultaneous equation. So simultaneous equation says that actually you can use minus. Okay, so you can minus down. Just take the equation number 4 minus with equation 3a. So if you minus, so 1 minus 3 will give you minus 2. 3a minus with 3a will give you 0. Okay, then you have minus 2b minus with positive 3b. This is give you minus 5b. Okay, let's just simplify this one. If you simplify this one, you will have your value of b that is 2 over 5. Okay, now once you have known your value of b, you can get your value of a. So substitute your value of b into the equation number 3. So you will have 1 equal to a plus b. So b is 2 over 5. Okay, and you have your a is 3 over 5. Now once you have known your value of a and b, substitute them, okay, into the general solution. Okay, so substitute a equal to 3 over 5 and b equal to 2 over 5 into your general solutions. That is your equation number 1. So you will have y equals to, okay, now you know your a. Your a is 3 over 5 e 3x plus your b. So your b is 2 over 5 e negative 2x. Okay, so this is what we call it as particular solution. Okay, this is a particular solution for this example. Okay, let's just solve the fifth example. So just change the derivative into the m. So you have the m squared minus 2m plus 1 equal to 0. And you factor this one, you have m minus 1, m minus 1 equal to 0. And your value of m1 is 1. Your value of m2 is also 1. So this is a case that we say you have the real and repeated root. Since that you both of them are having the value of 1, so means that you can name it as m only. Instead of m1 and m2, you can name it as m only. So your m is actually 1. Then your general solution will be in this form. So the general solution will be y equal to a plus bx e to the power of m. Okay, the m here is 1. 1 multiplied with x is x. So let's just name it as equation number 1. Okay, so before we substitute the first initial conditions, okay, you need to figure out what is your y prime. So differentiate this one. So differentiate your first equations, but differentiate your first equation, you need to use the product rule because you have the x in here, okay, and you also have the x in here. So you're going to use the product rule to do the differentiation. So product rule says that you have y prime equal to u dv plus v du. Okay, let's just differentiate it. Okay, so if we differentiate it, we have the y prime equal to u is a plus bx. And your dv is actually e to the power of x. Okay, plus the v here. The v here is actually ex. And what is your du? Your du is actually b only, right? You differentiate this one, we have b only. So I don't want to expand this one. I just name it as equation number 2. Okay, I'll just look at the initial condition directly. So let's just substitute the initial condition. So let us substitute y0 equal to 1 into the equation number 1. So if you substitute y0 equal to equation number 1, so it means that your y is actually 1. So you substitute into here, you have 1 here. Okay, a plus bx, so you have a plus bx. The x here is actually 0. Okay, then you have to multiply with x. The x here is actually 0. So let's just simplify it. So you have b multiplied with 0 is 0. So a plus 0 is a. And then you have e to the power of 0 is actually 1. So we have your value of a is actually 1. So once we have known our value of a, then we're going to substitute the second initial conditions. So you're going to substitute your y prime 0 equal to negative 2 into your second equations, because the second equations has the y prime here. So it means that your y prime is actually negative 2. So we have negative 2 equals to a plus bx. So we have a plus bx. The x here is actually 0. Okay, multiply with e to the power of ex. So e to the power of 0 plus e to the power of 0. Okay, multiply with b. Okay, let's just simplify the right hand side. So if you simplify the right hand side, I would have a plus b multiplied with 0 is 0. So we have a only. Multiply with e power of 0 is 1. a to the power of 0 is 1, and you have b here. So you simplify, you have negative 2 equal to a plus b. Okay, you have two variable here, okay, but anyway, okay, let's just name it as equation. But actually, we know what is our value of a. Our value of a is actually 1. So now substitute your value of a, that is equal to 1, into your equation 3. Then you can know your equation. You can know the value of b. So you have negative 2 equal to the a here is actually 1 plus b. So your b is actually negative 3. Now, once you know your value of a and b, substitute them into the general solution. So your a is 1, your b is negative 3. So you substitute into the general equation. So that is your equation number 1. So you will have your y equals to a plus bx. So a is 1 plus bx. b is minus 3. Minus 3 multiplied by x is minus 3x. So e to the power x. So e to the power x. So this is what we call it as particular solution. So this is the answer for the example number 5.